Today, let us start with factor theorem. If you have px as your dividend and the degree of dividend it is 1 or more than 1, and you have a number a which is a real number which is in the divisor, then if in place of x you replace a, you will get the value is equal to 0. Then in that case we say x minus a is a factor of px. Okay, if you have dividend p of x, you divide it by a divisor x minus a. So that means with the help of remainder theorem, the remainder will be in place of x. In place of x we will replace with a. That means you first find the remainder. Then after you find the remainder, you find that the remainder is equal to 0. So with that, it means the number, this divisor, it will become a factor of dividend. So with the help of remainder theorem, if we have px as dividend, x minus a as a divisor, with the help of remainder theorem, we find the remainder, we get it to be 0. So if the remainder is 0, then with the help of factor theorem, we can say that the divisor is the factor of dividend. Okay, so this one, remember, it is a continuation from the remainder theorem only. You see, p of x divided by x minus a, then remainder you have to replace p of a. Then you calculate the value, that means everywhere where there is x, replace with a. So after you calculate, you see if it is equal to 0, it will be a factor. If it is not equal to 0, it is not a factor. So the same way, if you divide by x plus a, then the remainder will be p of minus a. So here also you have to find. If you get it equal to 0, then we can say x plus a will be a factor. Then you may divide it by ax minus b. Then remainder will become pb by a. There also, after you calculate, if you get the remainder to be 0, then it will be a factor. If not 0, then not a factor. Okay, or you may have two factors, x minus a, x minus b. Then here you have to find two remainder. One in place of x you replace a, another you replace b. So if you get the both case equal to 0, then both this factor will be the factors of p of x. Then if they are not equal to zeros, they are not the factors. Now let us see exercise 2D. Applying factor theorem, we have to prove that these divisor, they are a factor of dividend. I will do number 1. Number 2, try it as your homework. Okay, we have this one as dividend. Let us write it as p of x. This one as the divisor. So we can rewrite it this way. Okay, we can write p of x equal to this one. Then remember, it is divided by x minus 3. So to prove whether it is a factor or not, we need to find the remainder. So here we will find the remainder. P will remain p with the help of remainder theorem. Here you see we have x minus 3. So that means in place of x we have to put the value of 3. So now wherever there is x in this p of x, you replace with 3. Then after that you calculate to see whether you get 0 or not. So here we have x to the power 3. We can write 3 to the power 3 plus, in place of x again we have to replace with 3 to the power 2. 17 into x, that means 17 into 3. Then plus 5. 3 to the power 3, that means you have to multiply 3 into 3 into 3. 3 into 3, 9. 9 into 3, 27. Plus 3 into 3, 9. 3 into 7, 21. 3 into 3, 4, 5. Plus 5. How many plus are there? 27, 9, and 5. So let us add them together. 9 plus 7, 16. 16 plus 5, 21. 2 plus 2, 4. 4 plus 1, we get 5. So 51 minus 51, we get it 0. So since remainder equal to 0, we can say that, okay, we can say that x minus 3 is a factor of px with the help of factor theorem.